Okay. The basic idea of this is what we want to do is we want to create a problem so that when we factor it, we get the exact same factors so that we can turn them into squares. So the concept is if I take something that looks like this, whenever I factor that, it would factor into this. Since those factors are exactly the same, I can write it like that, which is a square. So the idea of completing the square is we have something that looks like this. We want to add on a term so that we can complete this square. Now, what we're going to do is we're going to kind of use that concept of factoring. There is a formula that makes it really easy, but what I'm going to do is I'm going to start off with the idea behind it, and then I can show you the formula. But I really want you guys to understand the math behind it to start off with. All right, so if we were doing this, I'm just going to start off with labeling this as question mark. If I wanted to do this as a factoring problem, I would need to find two numbers that multiply to that question mark and add to be 6. Now, I know that whenever I factor this, something like that. We'll get to the formula. Okay, now it can't be any number I want. All this has to be very specific. Okay, whenever I factor this, in order to be a squared, I need both of these numbers to be exactly the same, right? Okay, so how can I split up x or 6 so that these two numbers are exactly the same? Dividing it in half. So I need those two numbers to be exactly the same, so I'm going to split that into 3 and 3. So that means what number needs to go right there? 9. Okay, you see how all that worked? I mean, once you figure that out, it all kind of works really fast. So we know that these two numbers need to be the same. So there's only one way to split up 6 so that those two numbers are the same. 3 and 3. Well, so 3 and 3 make 9. So this number has to be 9 in order for it to make all this work. So if that's 3 and 3, then that's going to be x plus 3 in there. So then the formula to make that work, this is the formula they give. I mean, honestly, I prefer thinking about it like this, but this is the formula that they give. You take that middle number and you square it to get the C number. You take B divided by 2 squared to get C. And then inside your parentheses, you have the number before you squared it. So if you're more of a concept person that, if you know the concept, you just need to know that you split that middle number in half. Then there you go. If you're more of a formula person and you prefer to memorize the formula, there you go. Okay. This is completing the square. Problem is using it in equations and that kind of stuff where you have to use it. But this is completing the square. All right, so example 2. What we need to go here. What over 4? Yeah. So what would go in here? What sign? No, you only get to pick one. It's going to be minus. Whenever you split this in half, you're going to have a negative. So depending on which way you think about it, wherever you split this in half, that would be negative 5 halves and negative 5 halves to get negative 5. So wherever you square it, wherever you square these two, that's always going to be a positive right there. But whenever you turn them into factors, they'll still be negatives. So this sign in here always matches that sign over there. Okay, are you okay with the concept? Do you want me to do another one? Okay, in order to complete the square there, what number do I need to add on? 36. Because I take half of 12, which is 6, and I square it. Which means over here, what are my two factors? X plus 6. See, sometimes I think it's almost easier if I take and I come over here and do the factors first. So if I take that and split it in half, what's that going to be? 7 halves. So if I take 7 halves and square it, what number does that mean that I need to add on over here? 49 fourths. One more, and then we're going to move on because we're doing this throughout the entire thing. Let's see. Let's do... let's make that a minus. Okay, so over here, what's going to be over here? X minus 1/2. So over here I'm going to add what? 1/4. Alright, so this was negative 1. I split that in half, which would be 1/2. Negative 1/2. So then I square negative 1/2. So that's 1/4. Now at this point you might be thinking, well, why do I need this? Well, because we're going to be working with equations, so we can't just add something for nothing. Okay, we good with this? Alright. Yeah.
Why does plus 7 over 2 come into negative 1 over 2?
No. These are separate problems, Manny. Okay. Each one of these is separate. One of those has nothing to do with the other one. So yeah, 7 over 2 can't turn into negative 1 over 2. Okay, so let's do a full problem. Now, these are your easy ones. They're going to get harder. So we're going to do easy, harder, and then hardest. All right. Now, when we do this, what we want is we want to work with completing the square. So we don't really want any of the rest of this. We want it back to what it was looking like in the previous page. So what I'm going to do is I'm going to get rid of that -4. So first step with any of these problems. Now leave a space so you can add on that thing that you needed to add on. But first step is just to move that -4 over. It will matter for our answer. I mean, it's going to matter whether there's a 4 there or a 10 there or, -32, because that's going to change what our answer is in the end, because we're solving for x. But for completing the square, it doesn't matter. Okay, now we need to complete the square. So let me go ahead and write out the next couple steps. So I need to figure out that number there so that I can do this step here, right? Now, if it helps you have the parentheses there to figure out what needs to go in the space up above, great, put it there. Now, I put a couple lines on that step above. There's a reason for that. Let's just work over here to start with. All right, I need to figure out what number I need to add on. So what's half of 10? 5. So that tells me whenever I factor, I'm going to have +5, right? So up here, what do I need to add on? 25. But now I'm working in an equation. I can't just add 25 whenever I want to. In order to add 25 on the left-hand side, I have to add it on the right-hand side. Now, this here, this step right there, that's fine. All I'm doing is factoring, just like what you were doing yesterday. I can do that without any worries. So this step, I just know how it factors, so I don't have to go through all the steps. I could come over here, well, let's see, two numbers that multiply to 25 and add to 10 are 5 and 5. Then I split it. I don't have to do that because I intentionally set it up so it would factor a certain way. So I don't have to go through my factoring steps because I made it factor exactly how I wanted it to. So now I have this. Okay, I'm done completing the square. I completed the square right here. That was completing the square. Rest of it is just solving. Okay, now I have something with a square. How do I solve something with a square? Okay, my last step. There we go. Square root of 29, I can't figure that answer out, so I'm just going to leave it because it doesn't work out nicely. At this point, I'd really prefer not to have decimals from you guys. And we'll work through simplifying square roots. If you have a calculator to simplify it, great. If you know how to simplify it, great. If you don't, just leave it. But I don't want decimals. Okay, next one, same thing, just gives us some fractions, so let's work through that one. But same general steps. Again, if it helps you, we can go ahead and write out this step. Okay, so let's see, half of that would be negative 7 halves. So if I square that, what's that going to be? 49 fourths. Okay, let's see. To add that, I need to change that into fourths. So negative 12 would be negative 48 fourths plus 49 fourths is 1/4. Okay, square root both sides. Okay, add 7 halves to the other side. So x is going to equal, this gives me 2 answers. Just to make sure that we're all on the same page. This means we have this and this. So this is 8 halves, which is 4. This is 6 halves, which is 3. Now, this is why we factor. That one, I could have factored that one really fast. 2 numbers multiply to 12 and add to negative 7. Negative 3, negative 4. So my answers would have been 3 and 4. No, there isn't. That's why we factor. But, can I factor this one? That's the point of doing this. Completing the square will work on every single problem. Factoring won't. Factoring is one of those shortcuts. Factoring may be horrible, but it's a shortcut so we don't have to do completing the square. Okay, so a little bit harder. Problem with these is we have a number in front of our x squared. I never showed you any like that, right? That's because we can't do completing the square if there's a number in front of the x squared. So what we have to do is we have to get rid of that number. Now, you can do it one of 2 ways. You can move the 9 and then divide by 3, or you can divide by 3 and then move the 9. Your choice. You get, I'm all about freedom in here. Math is all about choices, right? Doesn't matter which way you do it, as long as you do it correctly. But one way or another, we have to get back how it looked on that first page. So we have to get rid of that 9 and we have to get rid of that 3. So now I can divide everything by 3. So now it looks like it did on the other page. And now it looks like the last page where we just go through a normal problem.
So does the really take out, like, the anything,
Just kind of gone. Now, you know from graphing that 3 actually made their graph skinnier, but we don't care.
So you're saying that
We're finding,
I don't have to use it again?
nope. What we're doing is we're finding like the x-intercepts of our graph. Yeah.
Okay, can you put like, at the beginning, divide both sides by
And then you would just subtract that. So then you'd have a 3 right here. So then you subtract your 3 to the other side. Okay, so what all do I need to fill in? What number goes in here? Minus 2. What number am I adding on? Plus 4. So I need to add plus 4 onto each side, which gives me a 1 right here. So I square root both sides. Add my 2. So x is going to be 3 and 1. Why don't you guys go ahead and try the next one? I'll just give you the answers. All right, I'm going to start working through it, so don't look up unless you want to see the answers. Yeah. Yeah, go ahead. Okay, I would take either one of those answers. We have not discussed eyes yet. We will discuss eyes in this next chapter. So if you are not okay with eyes, you do not feel comfortable with eyes, that is fine. Whenever you get to square root of a negative number, I am okay with you writing that it does not have any real solutions. Do not write no solution, because you should know that it has a solution, it just doesn't have any real solutions. So that's up to you. I will accept either answer. You just need to make your choice. If you're going to do this, I expect this to be right. So make your choice wisely. But by the time we get to a test, you'll be expected to do this. So just realize that. We will have a quiz on Wednesday. I will try it, unless I mess up, you won't have anything like this on the quiz. You'll have problems where you have to do this. Unless I mess up on a problem, you won't have any eyes on any of the problems on the quiz. On the test, you will. By the time we get to the test. Okay, hardest one. It is not hard concept-wise. It is hard math-wise. Because you guys hate fractions. Yeah. You want to try it yourselves, or do you want me to do it? You want to try it yourselves? Try it. Do it yourselves. It's fine. Like I said, there's nothing difficult in it concept-wise. It's math-wise. All right, I'm going to go ahead and start working through it. So if you get stuck, you can look up and look, but just be warned that there's going to be work up there. Bless you. Yes, thank you. Sorry. Okay, there's what I got, as long as I didn't make any other mistakes. I messed up my 4.
Why is the eye behind you?
Complex numbers are in this form. So you should have a number plus a number I. So here's my number plus a number I. So I'm putting it in standard form. So the I should not be part of the fraction. If it, I mean, if you did, there's lots of different ways you could write it. I could write it like this. If you did quadratic formula, it would originally come out looking like that. And like I said, there's lots of different ways you can write it. Yeah. square root it. Where you square root the 100 on the bottom, you get 10. So wherever you do square roots, you can split up your fraction and square root each piece individually. Like that. Sorry, this is what happens whenever I make up problems on my own really quickly. But this shows that you can use this on any problem also, which is the point of it. This is why I just make up random problems sometimes. Because I know no matter what problem I make up, I can use completing the square on it. Whereas, if I was doing factoring, I'd have to take my time and make sure I make a problem that is actually factorable.
My question is that when in real life would I get that kind of command? Like when would I get 5x squared constantly?
In real life, you probably wouldn't.
When would it
Let me give you your assignment, then we can talk about it.
like my question is if I'm filling
No. Okay. A normal in everyday life, you want it. It depends on what your job is. But no, a bus driver is not going to use this. An accountant isn't going to use this. It depends on your profession. But in education, we're educating the masses. We don't get to educate you by individually. And a lot of you have no clue what you're going to do in your life, even if you think you do.